all right. Good morning, good afternoon, good evening, wherever you're joining us from right now. It's good to have you all again join us today, being the third and the last day for this particular episodes of Azure DevOps training. And we're excited that you've been able to follow us through the journey since we started on the 21st, which is Friday of this month of April 2023. We are excited that to allow that you indulge us with your time. It's been a very interesting series. We've been able to look through the Microsoft Azure DevOps. We've been able to see how the DevOps instance, looks like in terms of the possibilities of DevOps around the boards, the repositories, and a few other things. We've also been able to, go forward to see how repositories are cloned, how you can deploy a simple application back to your repositories, how you can spin up some sort of Docker containers, and all of that. So we've been able to, go through a few interesting things, and definitely today we'll continue from that. See how we can also move towards a few things around it. You know, virtual machines and a few other things like that within the Azure DevOps. All right. And we're excited that you're following us on the journey. Yesterday, some people were able to, clone their repos, push their applications, push their code base to the repository and all of that using Git. And that's a very interesting one. And like we said yesterday, that we are not going to be overloading you. So, which means even after this series ends today, definitely we're coming back again very soon, if not next month, probably sometimes before the end of this particular quarter. We'll definitely come back again and continue with you. One of the things that we believe that makes anybody solid in whatever it is they do or they learn is consistency in doing those things, right? So even though this particular episode ends tonight, today, all right, but as a team we promise to come back again, all right, before the end of this quarter. I'm sure this quarter ends in June, so it means if you don't see us in May, you would see us in June, continuing this Azure DevOps series, all right, which means whatever it is we've been able to show us within these 3 days, put them to practice so that when we come back again, we continue from where we stopped. And that's why we're happy that the videos are on YouTube, all right, on this particular channel on YouTube where you are. So you can always go back, track through the things we've learned. All right. Also, leverage on them, and when we come back again, we'll just continue from there, and connect. Technology industry is it's all about connections and networking, right? I already dropped my LinkedIn and Ekene's LinkedIn in the chat. Reach out to us. Let's connect and all of that. And like I said, because of the time constraint we have, there are quite a few other things we would love to show, really. But like I said, it's something we'll push forward. But I promise that very soon, we're going to do a series on Azure DevOps for low-code engineers, Azure Dev, and we'll pick other aspect of Azure DevOps. Don't worry, it's a long series, and then we'll take it step by step. But at least for this episode, it ends today, and then I want you to keep practicing, keep doing it, keep testing it out. If you have questions, reach out to myself, reach out to Ekene. We'll be able to answer questions that you might have and all of that. It's a very interesting ecosystem, all right, and we're excited to be on this journey with you. So welcome and welcome once again. We will not waste our time today. We have a lot to do, and as people of integrity, we definitely by 9 West African time we release you to be on your way. All right. So I'll bring on board Ekene, who I'm sure has been a fantastic, you know, instructor to us in the past 2 days, to continue with us tonight, and then we'll definitely have a blast. Good evening from your side, Ekene. Uh, Hello, Ekene. Can you hear me?
Good evening.
All right, good
Evening.
evening,
Can
good
you hear me?
evening. Yes, we can hear you loud and clear. We can hear you loud and clear.
Okay. Let me on my video. Okay. Good evening, people. The
Good
journey
evening.
is gradually coming to an end. So, today is just going to be a very fast one. We are going to take just two topics today. One is infrastructure, which we are going to see. We'll learn about virtual machine. Then secondly, we are going to build a pipeline. How we'll develop them and push our code to just take a simple code and push it to Azure App Service. Sorry about those who wanted Docker. Because of the free service, you cannot really deploy Docker to Azure because you are using free service. There are some restrictions that comes with the Azure free account. So we'll not be able to deploy the Docker containers to Azure. But for app service, we can deploy. So that's what we'll learn today in the pipeline. So let's get started. So let me share my screen.
All right. So for people joining us,
Okay.
definitely
Open up.
we are working on. We'll note that down. We'll note that down for the next series. We'll definitely have our paid subscription up so that we can, we can show you some of those deployment to Docker containers that require some sort of
Yes.
Azure
Yeah.
standard licensing. Yeah. All right. Thank you very much, Ekene. Please go ahead. I'm just going to mute my mic and also
Okay.
listen.
You can see my screen now.
Yeah, we can see your PowerPoint.
Okay. So okay. So this is just day three. We are going infrastructure, create VM, ISO with Terraform, then with pipeline, setting up a pipeline to push our code, then questions. Simple. So let's start is the building block of a virtual machine. Yesterday I described a virtual machine that is a full-fledged computer on the cloud. It can be an OS, it can be it can be a normal Windows 10 desktop, it can be a server, it can be just a server or an Windows 10. So whatever machine you have, you can put on the cloud. So it's a virtual machine. It's not a full-fledged machine like what you have on your desk right now. So what are the building blocks of a virtual machine? If you want to create a virtual machine and it's working, what are all the requirements for a virtual machine? So you have the virtual machine, which is a virtualized computing environment created on top of a physical hardware. You have the operating system, you have a data disk, you have a virtual network, you have a network interface card, you have a public IP address. If you because if you build a virtual machine, you want it to talk to the outside world, except you have some restriction like your database. You may not put public IP on your database, but you put your normal local IP in your database because you don't want it to talk. But for your web servers, if you have a web server, then you might want to expose the IP of that web server to the outside world. But most times, people don't put the IP of the web server. They rather they put the IP of their load balancer. If you have a load balancer, or if you have an API gate an application gateway, you put the IP, but not really the IP of your web server. So, but at the end, but in all, you need a IP address. They have a network security group, which they kind of is a virtual firewall. If you have a category of servers you want to restrict access to, you use network security group. It's okay. These three servers, these are my firewall server, my database server, and my other servers that I have like payment. So they can be in one security group that nobody can talk to them. So they can now from that security group now they will have just one IP which they can give out. But within them you cannot talk to only those servers within that security group can talk to each other. If you're not in that security group, you cannot talk. So it's a level of security you put when you're developing your infrastructure. You have availability set. Availability set is a combination of similar virtual machines that can scale up together or scale down together. You can create an availability set of say, okay, I have minimum is one machine, maximum is seven machine. So if my load increases to 5% to 20%, add one virtual machine. For every 20% my traffic increases above this threshold. My threshold is 5,000 hits per second. So if I get 20% of 5,000 hits per second, add another virtual machine. If it adds to another 20% again, add another virtual machine. If this drops, if it drops, drop the virtual machine. So we're getting availability set, you set all these rules. But we may not really go into creating availability set right now in this lecture, but subsequent lecture will show you how to do all this. Then you have a load balancer. Now, in that availability set, you want that, okay, I want three virtual machines to be up at the same time. But I but now I there is what they call round robin. Give it to the next available one. That's round robin. If a request A comes in, give it to virtual machine A. While virtual machine A is processing and request B comes in, give it to virtual machine B. While B is processing and C is free, give it to C. So give it to the next available person. So that's round robin. Who is the next available? But you have different types of load balancing. You have geo- geographic load balancing. For people in US, they should hit this server. People in Nigeria should hit this server. That's geographic load balancing. So we have endpoint load balancing. There are various types of load balancing. It's a whole topic of its own, which we may not be able to take in this class. But I just give you an idea of load balancing. It's just to share traffic between back-end virtual machines. You have three virtual machines and you want to share traffic within them so that you're not overloading one virtual machine. They have Azure Bastion. Azure Bastion is new. It just came in just less than 3 years ago. Is before we used to use either SSH or RDP to log into virtual machine, but that has a lot of security risks because you expose the public IP of your virtual machine to the public. So they use Azure Bastion. Azure Bastion is you're accessing your virtual machine on the cloud using your browser. You can access the virtual machine. We are going to see this when we create our virtual machine, how Bastion works. Then Azure Backup. Normally, you need to back up your whole virtual machine. Backup backup is something we know. So for recovery, then site recovery. Azure site recovery now is when you have to back up your data in another location so that you have a site recovery and they put your recovery time, your downtime, and the minimum time to recovery. Then you grab the last one, the Azure Monitor. Sorry, Azure Monitor is you attach it to everything that happens on your virtual machine. Monitor the health and security of your virtual machine, and it gives you updates. It gives you advice on what to do, and you can connect it to Azure Advisory. That's from the monitor. You can connect to Azure Advisory. That will tell you, okay, for this type of incidents, do this. So that's for Azure Monitor. So hopefully that's the basic things you need to know about Azure Virtual Machine. Then with the next thing, I will go to IAC with Terraform, where we are going to build our virtual machine. So what is Terraform? There are other types of infrastructure as a code tools. So Terraform is just one of them. You have Ansible, you have Terraform. You can also use CLI, command line interface, to deploy your resources to the cloud. You can also use PowerShell to deploy your resources to the cloud. You can also use Azure Azure Shell, which is a shell script, writing shell script on the Azure platform. But today we won't look at all those some wonderful tools. We just concentrate on Terraform, which is the most popular and the most widely used IAC tool because of his it has versioning, it manages your state, it keeps the state of your configuration, it keeps version, and it can deploy your infrastructure at any time. There is so much about Terraform, but we'll just go to the basic knowledge for you to see how Terraform is. But as for the configuration of Terraform, we'll not do it in this class because it requires so much to configure your machine to start working on Terraform. But you just appreciate what Terraform is, what Terraform can do. Then subsequently, we'll now go deeper. We'll have a whole 3 days class on just Terraform. But for now, let's see what Terraform can do. So as you can see, a complete Terraform. So we are going to look at the complete Terraform project. How does this? So let us start. Let's start. So thank you for listening. We are going now into the practical. So I'll show you a Terraform project and we'll
So we have a
talk about the
question before you
Terraform
go into the
project
practical.
and how it and the building block. Okay.
All right, before you go
Yeah, I've got
into
the
your
question,
demo, yeah.
please.
Dave was asking, how do users connect to the applications on the server with NSG?
You to connect it with network security group, you can't connect from outside. It depends on the security policy on those servers. But if you're on the portal and you're the admin, you've been given certain rights. Your IP address must have been put in the IP routing table of that energy. That okay, this with this part. So NSG will limit only particular IPs to connect to. Once systems are inside an NSG, they have what they call an IP routing table, and they have specific IPs that can connect to any server within that NSG. So your IP must be in the routing table of that NSG and must be whitelisted in the routing table before you can connect. If you are not on that routing table, you're not whitelisted, you can't connect to any server on the NSG.
All right. I hope that's clear, Dave. I hope that's clear. All right, let's go on.
Okay, so you see the building blocks of your Terraform. You have the provider, you have the resource, you have the data source, and you have variables. So we'll look at some of this in our project. So this is our Terraform project. So these are Terraform. Typing this as we are going on, but because of playing the building blocks. So first of all, you have your provider. You are telling Terraform that your provider the tools for this provider is coming from HashiCorp. Other tools have several API because all these things talk to an API. So if I want to, at the end of it, at the end of all these things, HashiCorp still uses CLI to deploy those infrastructure at the end after all this interface. So it's just giving you a fun interface, but at the bottom line of it, because Terraform is built using Go, so the Go programming language. So at the end of it, all the thing is converted to Go, and Go now is now converted that to a CLI or an SDK to now build it. So you can decide to have an SDK, software development kit, like you can use Python to deploy your infrastructure on Azure. But Python, so many things. But this one is just straightforward, it's readable, and it's easy to understand. So you're telling that okay, use the APIs for Azure Resource Manager. Why Azure Resource Manager? Everything that is on Azure comes from Resource Manager. You cannot put anything on Azure. So Azure Resource Manager is like the guy, the service that's used to deploy resources in Azure. Everything you deploy in Azure below the subscription. After the subscription, you now go to resources. So everything now from below the subscription comes through a resource manager. So you must have a resource manager aside from IM and the rest, which you don't have resource manager, but every other resource or service comes from resource manager. So you're telling HashiCorp, you're telling Terraform, this is what I want to use. It's for AWS, you use AMI. Um, Amazon, you use AMI to do your management interface. Use AWS here. So I'm telling you, so what's my provider? I have Azure Resource Manager. That's my provider. This feature block must be there, whether it is empty, whether you have something in it or not. Without this feature block, this application will not run. This is kind of what you call a constructor when you're building a class. So this feature block must be there when you're writing this code. So now after this, I now have my resources. You see my resource name, Azure Resource Group. Then you see my unique identifier. So why this unique identifier? I can decide to create another resource group like this. Try to say, let me create another resource group. So you see, I have my IntelliSense because I have put Terraform on my Visual Code. That's some of that into the what are the extensions you can put in Visual Code. I added Terraform, so it's giving me IntelliSense and this code completion. So I say resource. I'm creating a resource. It just gave me this. Let me just remove it. So let me create a resource and I give it Azure Resource Group. So since I have this unique identifier here, to create, I need to put two here. So this identifier, I create more resource group, but this is a unique identifier. This is telling me that these are two different resource groups. If I don't put this, it will create this, then use this one to overwrite what I have here. If I leave two of them with the same identifier, I'm creating two resource group with the same identifier. So if I do this, it will when it comes to this block, it will overwrite what I have put here with what is here. So that's how Terraform works. So you have the resource name. This is from coming from Azure. You don't create this one. You must use the exact name as Azure calls it on Terraform. So this one you don't change, but this is the one you change. This unique identifier. Just having the same unique identifier everywhere, but the resource is different. So I can have the same unique identifier, but with different resources. So don't mind that you are seeing the same unique identifier, but the resources are different, so it doesn't have any issue. So this is my so these are all the resources I'm creating an Azure VM. So and as we said, the building blocks of a VM. So what am I building now? First of all, I created my resource group. After the resource group, I'm creating a virtual network where my VM must be on a network. If I'm using the portal, all this will be created by default. If you're not using the portal, you have to most times asking on interview because most of people don't want you building things on their portal directly. So you use infrastructure as a code. So you need to know this as you're going in for DevOps engineering. They have your please hope that says my screen is still visible. Hello, Ayo.
Yes, we can see your Visual Studio code.
Okay. And I'm clear.
Yes, you are clear.
And I'm audible enough.
Yes, sir.
Okay, so I now create a virtual network interface. I'm creating my interface. This is location. So you see, look at something here. I'm creating this subnet. So which resource group I'm using? Because everything was being a resource. I'm using Azure Resource Group, right? And I now call the unique identifier. Use this unique identifier. And what is it? The name. And if I come to this resource group, I've created the name. This is the name here. So this is the name of my resource group. So you see, I'm using what I created before in another place. So it is no resource. As I said before, you cannot build any resource or service on Azure without a resource group. So if you look everywhere, we'll be mentioning that resource group because we have created it and we are using it. So just pick the name of the resource group which you created before and put. If I want to use this location, I'll just put the resource group, this Azure resource group, and I pick location. So everything will be so I don't need to pick location again because the resource group. So if every device will be my resource group in the location where my resource group is by default, but I can decide to change my location. I can build services or resources in the same resource group but in different region, but they are still sharing inside the same resource group. So I have my network, I have my NIC, I have I have my public IP, which you mentioned, I have my virtual machine, and I have my storage disk. So these are all the resources. The operating system, this is my operating system, admin username, this is the username for the admin. Then this is the admin password. This is the profile, which what am I using? I'm using OS Linux config. So I've created my OS profile. So let's start. So the first thing now, we'll now do Terraform init. created a file. So must end with .tf. So what Terraform will do when it's building, it will look for all the .tf files, and then it will now join all everything together and build as one. So no matter where you put it, no matter the folder you put it, so it will go into this your root folder, look for all the .tf files. So this main.tf doesn't really matter. I can put anything, but it must end with tf. That's what Terraform will be looking for. So I now say Terraform init. Remember the configuration part where I need to connect to my Azure account. So with that, we have not done yet. We've skipped that part before we came here. I must have created a service principal. You need the service principal in order to connect your Terraform to Azure. So I've created that service principal. It's through that service principal I'm using to talk to Azure now. But we didn't go through that. It's a whole long process. And if we start that, we may not have enough time to complete it. So I'm just assuming we have skipped that part. So it is installing HashiCorp. First of all, it finds this. It's found it. Then it's installing the version. Let's give it some. So we now do Terraform plan. Terraform plan out. Terraform, sorry, yes, Terraform plan to show you everything. Okay, this is what you are changing. This is what you are deleting. This is what you are updating. Everything as it is. What you want to do before you do it, so you can go back and change it again. Whatever you want to change, you can go back and change. So I'm running Terraform plan. Some time. Showing you why this one is taking its time. Okay, so if we look at the plan, so this is our plan. Missing. Okay, we have some error. 1 minute 29th and resource Azure. Okay, sorry. We have some errors here. Let's correct them. So if you want to build any resource, there are some specific fields that are required. Like if you are building on the portal, they tell you this field is required. So line 29. Okay, we use address prefix instead of prefixes. Just subline 131. So it's prefixes. Let's do a plan again. Just want our plan again. So see that is see the error is giving us because it's required in Azure, but we did not correct it. We are looking at we put I need to run Azure in it. Let's hold on. This so elevation change. Let's see. Just fix this. So it's supposed to be now. Let's see. I just fix this should be st. Let's say stringify. Let's go.
Okay, Ekene.
Yes, to take I'm going to say this. There's something supposed to be there. So let me run Azure
Uh,
in it. So is there a
all right,
question
hello,
there?
Ekene. Yes, are you able to hear me? Yes,
Yeah.
quite a couple of them, quite a couple of them. But I think the very first
Okay.
one is
I
the
can
very
take it.
first one is more like the very first one is more like a request. So somebody was saying that can you please just
Hello.
tell us as you are hello, if you can hear me. So somebody was
Yeah, I can
asking
hear you.
if So somebody was asking if you can please
Yes.
just tell us what are each of those resources, all right? What each of them would do when you create them. So those resources you were working on, what would each of them do when you create them? So it will help everybody understand. So when you create them, what do they do? So at least they understand so that when they want to try it on
Okay.
their own, they can get the idea. So that's what somebody was saying that you can please do. So apart from that,
Okay.
then somebody then asked a question to say, uh, so in terms of when we're talking about the whitelisting, right? It says, so are we
I can hear
saying that
you.
the yeah was when we're talking about the whitelisting? So it's saying that are we saying that the users will reach the application through a proxy server that is already whitelisted, right? When we were explaining the whole this thing earlier, that will the user reach the application through a proxy server that is already whitelisted. All right.
Okay. So
So
if
that's
you
another
have put
okay.
some, if you have put your servers in network security group, those ones don't have any business with users. You get. So now I have a web application. My web application is in my public domain on the public server, which has a public IP. Then that public IP now has an internal IP. So it is that the internal IP of that web server that will be whitelisted in a network security group. Like in that network security group now, you have your database. That's all your databases are. Then if you have your AI tool, your AI server, that is where it will be. If you have your transaction management server, where like in the bank application where the transaction will be managed, that's the server will be. So these servers don't have any business. In short, they will not even have a public IP. They're going to have a local IP, and they will be inside a network security group with a local IP. And they will now and they have a network and they have a routing table. And in that routing table, you are going to add the IP of that web server that will talk to only the IP of that web server can talk to that network security group. So and it doesn't even go to the particular server directly. It just sends its request. So once it sends a request, it is now routed to the particular server. So it doesn't even know the IP of the server it wants to talk to. Do you get? So that network security group doesn't have any business with the users. It is the web server that has business with the users, and that web server has an internal IP, which internal IP is now widely listed on the network security group.
All right, fantastic.
Very clear there.
So what about this question? So another question says, what if you want to create, say, five instances, right? Five
Yes.
instances of this same virtual machine specification.
Want to create 5 instances. Is it the same virtual you is it the same virtual machine? For the same
I
virtual
would
machine, you
assume
just
I would.
then you are creating a skill set. You just put a skill
Mm,
set, then you now put number minimum and maximum 1 to 5. But if you want to create
yeah,
different virtual machines, then you need to add those specification. What you now be changing is the unique identifier.
a unique
You want to create
identifier. Yeah,
you want to create a virtual machine for your database server. You want to create a virtual machine for your web server. You want to create a virtual machine for your transaction server. So that unique identifier is what you will be different for each of them. It will see the same resources. Then one you want to use Linux for a particular one. Another one you want to use Windows. Another one you want to use Mac OS. So whatever you want to use, that's what you use to create them. So are we clear with that?
fantastic. Yeah, yeah. I think we're good. Thank you. Please go ahead. So please don't forget, when you are installing, when you are uploading those using, please let's explanation of the resources. Your screen is no longer screen.
Okay, my screen. I no, because I was answering the question. I know the screen takes a lot of data, so that's why most of the other question I had to shut the screen down. Okay, let me bring it up again. Just 1 minute. Let me bring the screen up. That's this stuff. Okay. Oh, network. I just shut them because network was. Just 1 minute. Hmm. Oh, how can I see this window again now?
Okay, so we can't see the screen yet.
No, just 1 minute. I'm trying to look for the particular window. Is I'll just share the entire screen then. The entire screen takes a lot of bandwidth. Okay, so you can see my screen.
Uh, all
Hello.
right, yes, we see it. We see it. Yes, yes, we see your screen,
Okay.
sir. We see your screen.
So
Yeah.
okay. So let me run this again. I join it. I run Azure plan. So yeah, someone was asking, what does each of them do? So let's start from here. This is Azure Virtual Network. When you build your server, they have to be in a network, right? So you put everything within a network. Or so you cannot have virtual machines within a network. Even if it's just one, it will be in a network. Oh, the argument long is required, but no definition is strong. Those had to write this thing down, and I didn't test it before this class. 169, please. Thank God. Thank you. You're debugging with me and see how it goes. This is the stress we go through. This is what you go through when you're debugging. Some because of the version you are using, some things may change from one version to the other. 169. Not seen this loan before. Loan is prepared, but no definition was found. Hmm. I've not used this loan before. Let's number three. Let's use this before. So let's go back. So everything must be in a network. Azure Virtual Network. As I said, this is the Azure name. It must be it is in. You have your virtual network. As you are building your virtual, you want to deploy virtual machine. You have to put a virtual network. Then a subnet now. You want to build. Now that's when you want to segment your network. You want to have a network for database. You want to have a network for admin services. You want to have a network for HR, network for, but everything is still within your virtual network. So if you look at it, chooses virtual network name. It is picking from this my virtual network. So I have a virtual network, and remember, virtual network can span between regions. So I have a virtual network. So from the virtual network, I am separating my network. I have different network. So what does that do? It helps for security and management. If you are in HR, you cannot easily talk to systems in admin. You need to have some privileges. You need to have some whitelisting to talk to that network. So it's for management and for cost management, so that you don't, if you want to know, okay, where are my costs so high? You can do proper cost management when you have your virtual machines separated by subnet. Then secondly, if you are running an architecture called spoke and hub architecture, so all your spokes now will now be in different subnets. While your hub, where is where your firewall is, and where is where your load balancer is, where you have your DNS server, they will be at the hub. Then each of the spoke will now be different subnets that are talking to that hub. Then the whole wheel now will be your virtual network. Also, you have everything. And then you now go to the next one, you have your network interface. This is the network interface card now for your virtual machine. So once you create this virtual network, you cannot assign it to your virtual machine. So IP configuration, this is the name. So if I then the subnet ID, which is the ID from my subnet. So I'm creating this interface now to my subnet. So this interface now is if how do I link link my subnet to another subnet? It comes through this network interface. Then the next one, I now create an IP address for my for my virtual machine. This is my public IP address, the resource group, my public IP address. Then the allocation method is dynamic. Uh, because I'm going to use some name, my name server, my DNS will be routing to this name. So I'm just trying to be fast here. Then this is my virtual machine, the resource group. So I'm not see this network interface which I created here. I'm not attaching it to my virtual machine. You see, so that's why I've attached it. Then I'm creating a storage disk. There's a default storage disk that comes in this virtual machine. If I'm trying to create an external storage disk, in case this virtual machine goes down, I will not lose my files. This is my OS. So the OS is outside the storage machine. Then I have my data. I'm separating operating system and data. So So this is where I have my data, stringify data disk, then caching, read write, I put my data, then the OS profile for my virtual machine. Then I'm using the Linux OS for my virtual machine. This is the OS I'm using, the Linux OS. Then I create a tag for this virtual machine, which is test. I'm using it for the environment I'm running on the test is test. So the plan has worked. So let's see now it will show us a blueprint of what we are creating. This is our plan. It's telling us that Terraform used a selected provider to generate the following execution plan. What is it going to do? Terraform will perform the following actions. It will create this network interface. These are the things that will be created for a network interface. So it's showing us everything will be created. So if you look at it, you don't like it, you can tell it that okay, you can go back to your code and change your code, whatever you don't like. So this is your plan, and we are done. You didn't use the output, so we now say apply Terraform. So we are now going to apply. So I don't know if I answered that question. I hope I've able to explain all the two. There are several things you can add. So I hope I've able to explain all that is required to
Yes, yes,
add
yes,
as
yes.
long as far as
So,
file is concerned.
if you're creating three different VM for the same say subnet, yeah, and say for the same
Yes.
VN virtual network, what would the TFI, what will it look like?
So this is my VM now. Look at this is the VS. If I copy this thing now, this I come here now. That's still the same configuration. I'll just change this to VM2. I'll give a unique name, database. I set SQL DB. I can change whatever I want to have here now. So this is it. It's like a thing here. It will be different from what is above. I can add it for other VMs. Are we clear with that?
That's clear.
Mm. Yeah. So it's applying.
All right, let's move
When
on.
it's done. So there are several things which you need to know in Terraform, like this state file which has been created. This is a state you cannot open it. This is the state of your Terraform of your cloud. You get so most if you have several developers, you will not want developers tampering with the state because it's a security issue. If anyone tampers with the state, it can bring down your whole infrastructure. So this state is saved somewhere in your blob in your Azure storage. So that's another security measure, but we didn't do that here. You create an Azure storage where you save your state file. So every developer that works is in safer because tomorrow if I want to create if I run this same and apply again, it will not create these resources. Yeah, this also will not be created again. Uh, if I want to remove, I will now change, I will now add a tag here to delete. If I want to delete any particular resource, I'll just add resource delete. So when it's created again, it can delete that resource. But if I come to this resource and I add something, yeah, it will create this, it will not just go and update. Like if I've created this one and I want to change the disk size, I just say change this size to 200. what it will do, it will just go and update. It will now see that okay, something has changed. It's just like version control in your application. If you work on a particular line of code and you commit and you push to your repo, if you change anything, it will tell you that just one line and it will show you that line that has changed. It's the same thing here. So if I change this thing to 200, it will now update this particular VM with a disk size of 200 gig. It will not delete it, it will not overwrite it, will just update, add the change. So that's one advantage of infrastructure as a code. So everybody is seeing what has been done, and you now have a full-fledged blueprint of your cloud infrastructure. So it's applying. It takes some time. So please, more questions, please. This is one key part for DevOps engineers. If you're a DevOps engineer, I can't do IAC. I don't think there's any DevOps engineering interview go where they will not ask you for IAC. So there are various IAC tools. So at least you know one, you know Terraform. So please, we need more questions. While it is applying, so it has applied. Enter value, it tell you that only yes will grant you to do that. So I say yes. Ah, so you I press Y instead of yes. Sorry. I'm supposed to type yes. I went and press Y. The normal Y we know. Sorry, please. So please, more questions. Okay.
So none for
So
now. None
this
for
is
now. We can proceed.
okay. Let this one. Sorry, I was supposed to press yes. I was supposed to type yes. I just went and press Y. But these people should know now that we always do Y or N. So Y should work. Oh, one. Mm. Oh, oh, until that one finish. Oh, we have so much resources and they are all new resources, so that's why it's taking some time. Okay, while that is running, let's move over to our pipeline. We'll come back to it, please. Let's not take much time. Let's move over to pipeline. So this is we'll go to our organization. My screen is still clear, right?
Yes, definitely. It is.
Okay. So we want to deploy our code to Azure. Let's do the basic setup. What are the requirements? What are the things you need to set up your pipeline for Azure? So the first thing you need is a deployment agent. So what is a deployment agent? It is the machine that builds your code. Remember, Azure DevOps is just a tool. It doesn't build your code. It doesn't compile your code. It's just a tool. It's just a pipeline. It's just an OS, a service on its own. So it does nothing. So the first thing you need is an agent. So how do we create an agent? The first thing we are going to do, we are going to so I go to project settings and I click on agent pools. So and this agent pool now, it can be a VM or it can be a server in your in your data center. It can be your personal laptop. Now, let me give you the advantages and disadvantages. VM is good because you can access it anywhere in the world. But what is the advantage of VM? VM, that means if you want to build on a Python code, you will need Python compiler on that VM. If you want to build a .NET code, you need Visual Studio Builder for .NET on that VM. If you want to build Node.js, you need Node.js on that VM. If you want to build Ruby, you need the Ruby compiler. So you start having different compilers, and that VM now will start getting large, and it is very costly. Remember, VMs, even when you shut them down, they still incur costs because they are they are occupying space. VMs are very expensive. So most companies would rather not go the route of VM. And if you are using VM, so they will not go that route. So you also have Azure hosted agent. But Azure hosted agent is very expensive because you cannot run parallel jobs. If you want to run parallel jobs, you have to pay. There are limits. It's costly. So what most companies do, and what I design for my company, is that we have a server in-house that sits on the demilitarized zone and has a public IP. This server now is what manages our agent. That's what we use to create the agent. So on that server now, any tool, any building tool we want to deploy, we can deploy on that server straight away, and we don't incur any costs. What it does is just build the application. Once it builds it, it now deploys it to Azure. Simple. No too much stress. Build and deploy to Azure. It doesn't keep the application. So once you build, you delete it and deploy to Azure. That's what the server does. But for now, we are going to use my local machine as our agent. You have pools. So these are the pools I've created. So I'm going to work with this Stringify training pool. So if you want to create a pool, you click on add pool. Your pool type is self-hosted. Your pool name, let's say 25 DevOps. Mm. They are grant access to all pipelines. So I can auto provision this agent to all pool in the project, in all projects within my organization. So this is my Unified DevOps training pool. If I go to the pool, let's see. Let me see if this one is done. Okay, this one is done. I now type yes. So this is the Terraform running. So I want to apply, so I type yes. It says only yes is accepted. So to go and build the resources in Terraform in Azure. So I'm now in this, so I now create new agent. I'm going to download the agent file. This is the agent file. I will download it. I will not, this is a Power script. So there's no need running this. So there's no need running this. So once I download, you say where you want to load it and load it inside this folder agent. I already have it, so I'll just replace what is there with this. Probably a wonderful place to. So this one is still running. So we are here. Any questions so far? So let me just, what do I do now? I'll stop this one and go to the folder directly. Okay, So this is still running. So the Terraform, hope we have all gotten one or two from how Terraform is used to deploy infrastructure, to deploy resources. So this is our cloud infrastructure as a code. All these things we see here, it will be the same thing we have in our cloud infrastructure. So this is our infrastructure as a code. Everything you see here is what you have in your cloud infrastructure. So that's what we mean by infrastructure as a code, because you have your infrastructure here. If I take this anywhere, it means this is how my, except somebody has gone directly to the portal and built something, or somebody has used another tool to build something. There's also what we call in Terraform, where you can pull. Once you want to start Terraform, you can pull all your cloud infrastructure. Everything will, you pull it first before you start building, so that it has everything can be managed with Terraform. Assuming you have used Ansible and CLI or whatever to deploy your infrastructure, and you want to start using Terraform, there's what we call Terraform pool, where it can take a copy of your cloud infrastructure and create a new state. Then from there, you can now start building your infrastructure using Terraform. So Terraform gives you that capabilities. I know somebody will be asking that question. What if we want to start using Terraform? What do we do? This is done downloading. See. Okay, this is done downloading now. So I've downloaded the agent folder. What I'll do, I'll just create another agent. Say A4, and I copy this thing there. Then you extract. So you see how we are building an agent. We want to build an agent where we use for So I'll change directory to what I just downloaded to my agent 4. Then I run my first command, which is config. Okay, the other one. So but let's go to Azure storage and see our virtual machines. Azure portal. Let's see what has happened there. I go to resource group. Stringify resource group. This is what we created. Stringify training resource group. So we click on it. Stringify training. So look at those things we created. The NIC, Stringify training NIC, Stringify training public IP, but there's an error with the public IP with the virtual machine. But I hope we understood how to do it. We'll resolve the errors and we'll move on. But this is, look at all the NICs, the public IP, and the VNet. So if I click on the VNet on it, so this is three spaces we give to it. So let's go to subnet. So if I go to subnet, so this is a subnet we created. So I hope we all appreciate what Terraform does. So this is a subnet we created under that VM. So let's continue. So any questions so far on this? So please, if you are
Yes, so
okay,
we have quite a few questions.
okay,
All right, so let me ask. So the first thing is 1 minute. So Dave is asking that if you're using a CI/CD tool, right? If you're using a CI/CD tool, do you think we still need something like we still need a build agent, say like Jenkins or Octopus on Azure DevOps? That's if you're using a CI/CD tool.
if you are using any CI/CD tools, remember you need a build agent when you want to deploy.
Mhm.
Jenkins, most times they are only continuous integration. They manage your code, but if you want to deploy, you must have an agent. So you cannot, because those tools don't build. They don't build application. They don't have anything to build application. So you have to have an agent to run your build.
All right. I
Mm.
guess that's clear. Also, let me see. Hmm, okay. All right, no problem. I think that's okay. They're asking, did you specify the that's the
Okay.
IPv4 for the subnet in your TF file?
Yes, yes. By default, if you don't if you don't if you specify IPv6, baby, if you don't specify anything, it will give you this. So I specify this as a range. So this is my Terraform. This is my address space. So by default, it will give me IPv4. If I want IPv6, I will not specify it to use it.
Mm. Oh, okay. And then somebody's asking that can you explain holistically what the agent will do so that they can understand you know why it is actually needed.
As I've said before, agents are the build platform. We get um, if you run a code on Visual Studio, right, and you want to build it, you have a build agent. There's MS Build, which is on your system when you install Visual Studio. So that, but if you don't have MS Build, you write your code, but your code cannot be compiled down to Visual Studio, C Sharp machine language. So that's what you do for the build. So you need a build because if you want to deploy an application to the server, you're not deploying your code. You are deploying a workable application. So that application now must be built and then deploy to your server. But if I'm just doing a static web, like I'm writing an HTML, CSS, and JavaScript, that does not require building. I don't need an agent. I will just do my CI/CD pipeline. What to just do, compress, zip it, then deploy it to the app service or the virtual machine. Do you get me there? Because I don't need to build. But once I need to build, once I need to compile my code, if it's Node.js, if it's Python, if it is because Python, I write Python in Django. So if it's Python, if it's C Sharp, I will need to build it. I will need a build agent to build that application to deploy. So that build agent now will have the compiler, which will now compile those codes to to a workable application. That's what an agent does.
So why should we then use CI/CD tool, right, if they cannot do what the build agents can do?
Because that is not what they are meant for. CI/CD tools are just to take your code and push it. They are meant to is just that pipeline. But the build agent, so I can create, so you need that build agent because that build agent is not there. You cannot like start putting, how many build agents do they want to put within their environment? Well, it's a cloud service. They too have to pay for that space. So you're saying if Azure DevOps now will put a build agent for Java, to put a build agent, it will put a compiler for Java, compiler for C Sharp, compiler for Node.js, compiler for Ruby on Rails on it. That's which some of them people may not need. So why do they want to do that? Except in the future, when they have enough space, they can do that. But they are self-hosted build agents. Like if we go to our pipeline, they are self-hosted. So you can start to use self-hosted. Yeah, but that one is expensive. So most companies don't use the self-hosted. They use their own build agent. Like if I go to Jenkins has self-hosted build agent, but it's costly. It's not free. Like on this our free tier, we can't use self-hosted to build the application. So when we get there, I'll show you that you can. There's an option to select self-hosted, but if you select it will tell you that you cannot. You need to send a mail to Azure telling them why you want to use that your repo. What is it meant for? Otherwise, you pay for it.
Yeah,
You
exactly.
get me? Yeah, so there's a self-hosted, they have a hosted agent, but it's not free. But for you to be on the safe side, get your, there's cloud hosted. Let me say there's cloud hosted and there is self-hosted.
MS Cloud hosted, yes. Yeah.
Yes, there's MS Cloud hosted and there's one with my own build agent. So every
Mhm.
CI/CD tool has it.
Yeah, definitely. All right, fantastic. Thank you so much. Let's move on. Let's
So,
continue.
so our build agent has run. So we are here now. I've created config. So it's asking me for my URL. So what's my URL? My URL is dev.azure.com. So if I come to this project, so that's my project together with dev.azure.com, it forms my URL. So I now paste it here. That's the URL I'm working with. It will ask me which type of authentication do I want to use. PAT means personal access token, and it's what is commonly used. It's easy. So you use personal access token to to do your pipeline. Remember, this thing I'm not doing as a developer, I'm doing as a DevOps engineer at the operation site. This is the partner, which this is the release part, the part between development and operation. So this is so developers don't do this. So developers may not have use their personal access token. Developers don't create agent. Is the DevOps. This is the work of the DevOps engineer. So I'm saying I'll use the default, which is part. I say enter, then I'll go and get my personal access token. I'll click on, look at where I'm clicking. This is my avatar. Then beside my avatar, you have user settings. I click on user settings and I click on personal access token. Couple. So you click on new and try stringify train. I give it full access and I create. I give it an expiration date. So you must copy it because after now you can't see it again. You can't see it again. So it's gone, it's gone. So I now come to my PowerShell and I paste. So it's connecting now to the server. So enter agent pool. So default. So we created an agent pool before. So there's our agent pools. So this is the one we created, which we want to use. I copy the name and I say enter. So enter agent. So now agent. So my system, that's my system name. I can use a different name. I can say what's the agent's name. So I just use my machine name. So scanning for two capabilities. So working directory. Enter run agent as a service. Yes. Enter enable service. I say yes. Enter user. I'm using my Windows user. Say yes. So I've created my agent pool. Service this started successfully. So if I come here, if I refresh here now, I go to agents. So this is my agents now. So agent successful. Supposed to be online. Okay, it's online now. So my agent can now start processing jobs, right? So the next thing we need to do, please note, you're putting an agent. The next thing you need to do is a service connection because you're talking to Azure. So you need to put a service connection where how the point of your code. So your service connection can be AWS. You want to connect to AWS. The frequency can be Google Cloud. You are connected to Google Cloud. It can be Oracle Cloud. It can be SQL CI. It can be whatever cloud digital ocean. So, but for now, you're creating a service connection to Azure. So new service connection. So it is in Azure Resource Manager. And now say next automatic. I can with those group here. So the free tier source group. So once I log in, I can now select my resource group. This is the default. I've created all these ones, but I can't use them. So I can use my default resource group. And I give it a service name. And file training SC test source connection test. Grant permission to all pipeline. And I say save. So if you are following, you just give us a thumbs up. Just give us a thumbs up or your favorite emoji that you are following, please. On the comment side, just give us a thumbs up that you are following. So this is it. The service connection has been created to Azure. So if I go to the connection, let me show you. These are all the places that see I can create a connection. So this is the one I wanted to use for Docker, but we cannot do this because of service, because of the free tier. If you want to create for Docker, you create a self connection for Docker container. So this is I'm creating for Chef, I'm creating for GitHub, Jenkins. So these are all service connections I'm connecting to. So now I am all set up for my pipeline. So now let me go and build my pipeline now. I go to pipelines. I start a new pipeline. YAML for now. So let's use classic editor because of time. I can't start right now. writing codes now. We'll just use the GUI to create a pipeline. So where are we getting our code? We can either get from Azure repo or from GitHub. So let's get something from GitHub. It's loading my GitHub now. I've select the repository from GitHub. So these are all my repositories. Let me find something on .NET. So this is .NET Core API. So please, it may break because it's a code that has not been fully, and I might have been working on it. So let's just use this .NET Core API. I select. I'm working from the master. So which type of application is it? How do I want to deploy it? I want to deploy it as an Azure Web Service into Azure. I'm deploying to Azure Web Service, not directly into a container. I'm into a VM. I'm deploying to Azure Web Service. So I now my agent pool, Azure pipeline. So my agent pool now, the one I built, we did stringify DevOps training. So you see hosted, which is Azure. They have private. So this one now, the agent pool is in Azure. I can use but for to use this one is expensive, as I said. So this is private, the ones I built. Then subscription, I select your subscription. You now select your service connection, not the subscription, your service connection, which we created. The service connection now has our subscription and all the other login details. Then for app service name, we put Stringify API. We put a name. But if you have created an app service before, you can select it from this drop down. It will show up here. App services under that subscription will show you. But for now, we don't have any. So that's why we can type the name. So we have done the first part, which is our pipeline. Then we'll now go to deploy. So this one, so Nugget restore. You now add Nugget rest. This is it because I selected app services. Just added these jobs for me by default. So I'm doing a Nugget restore. So restore all my Nugget packages, which are in my cs.push file. So I leave everything as it is. Then in that repository, I have a solution file. Is build a solution because it's a C# application. When you build, you archive the file, you run your tests, but I've not created any tests. Then you deploy. So this is a deployment now. So how do you deploy it? Application type, is it on a Linux or a Windows machine? So let's deploy on a Windows machine. So, in fact, so deploy as a slot on app service environment. We now create a resource group. We now create a resource group, which is Stringify API. Right, resource group. So my slot is production. If I don't have any slot created, so I just put production. So that's that. I now save and queue. So this is my agent. It's queued. The build has to start. Job preparation. So this is a job. So if I don't have MS build on this system, or if I'm not installed Visual Studio on this my system, this will not work. It will have to send it to my system to build it.
Okay. Can we use our local machine as a self-hosted agent for say
I'm using
several
my local
Azure
machine now.
project pipelines? Exactly.
Yes, you can use your personal machine, but for a company might not want to use your personal machine. They want it to be on the server.
Mm-hmm. On the server.
Yes. Oh, just 1 minute. Let me just get this video off.
Okay. So we'll just wait for the pipe. I think the pipeline is running, currently running. So let's just wait for the job to run. I hope we're learning something. I can see our comment already. I hope we're learning something. And Elijah, to what you asked us earlier, definitely, we'll gather the slides by next week. You'll get an email with the slides and the source code. Some of the source code we use, we'll gather them for us, and then find a way to push it down to us. We have all your details, so we'll definitely push it down to us by an email. All right, and we'll put some of those terminologies in the slide, try and explain some of those elements also in the slides. Okay. So no problem about that. Okay. So for task numbers, most times Azure DevOps assign task numbers um majorly automatically. So again, if you're back, somebody asked a question: are we using a single pipeline for the continuous integration and continuous deployment process simultaneously? I think for this one, it depends on you. Anyways, it depends on your project. I think if you're deploying to say a dev to staging, you might not have a different pipeline. Your process will determine the pipeline model you want to use for your integrations and deployment. All right, but again, you can answer that also.
Uh, Integration and deployment are two different things. Integration
Exactly.
ends with your code on Azure repo, on your repository. That's where integration ends. What is integration? Integration is all develop. We have a master branch. Developers have created their own branches. So continuous integration. Your pull request is not it's automated for that continuous integration. There is no once you get a pull request, it's automated to to merge with your test. If the
Merge.
test is done, when the test is done, then that your code is merged to the master branch, and that is where continuous integration ends. Why is it called continuous integration? Because there is no human interface for your pull request. Pull request is automated. Once I build my code, I initiate pull request. It's automated and it is tested. Once tested and okay, it is merged to the master branch. That is where continuous integration ends. Now, from that point now, there's a trigger. Once there's a change on the master branch, trigger my pipeline. So this pipeline, the build process started. It now runs its own tests. So once tests and approvals are automated, you now have continuous. So for once tests and approvals are automated at the code level, to mesh developers code to the master branch. Once it is automated, you have continuous integration. Now, when tests and approvals are automated at the deployment level, when there's a trigger, because at the point there's a trigger, who will run a test, and there's somebody who needs to do an approval. Now, if I now automate those two, testing and approval, and my code is tested and is approved without any human interface, without any human input, it's pushed to production, then I have continuous delivery or continuous deployment. Continuous deployment means my code has been deployed to a server, but it is not yet available for customers. So I can deploy, and then it's either I now do a corollary. I now say, okay, once it is deployed, let me deliver it to customers. But now continuous delivery is once it is built, tested, and approved, it is available to customers immediately without any other step. But deployment is there is a step to be checked before it is delivered to customers. Yeah.
All
So
right.
to integration and deployment, they have nothing to do with your pipeline. Your pipeline takes you to your deployment, while your repository is where you do continuous integration. So then they are two quite different. But you can have your pipeline to deploy your code to test to dev environment. You can have it to deploy your code to staging environment. You can have it to deploy your code to production environment. So it is left to you as Ayo rightly said. So we are running. So this is a job. So it has downloaded all the Nugget packages. So let me show you what is happening now. Let me come to this folder, in the work folder. See what is downloading. All these tools are coming from online. So this is the application. All these folders, you see these folders. If you can see this, my folders.
Yes, 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 yes. Can see it.
And so these folders now is showing that what this thing is running are the builds coming in. So you see the Nugget packages. This is Nugget, what has been downloaded in the application. So you see that my system is the one building that application right now. So there's an error. I said it before that application that has not been tested around for a while. But I hope we all follow up. At the end of this your code, everything will run smoothly. So there's an error. Solution not found with the pattern. Okay. So I didn't see this. If I go to my work directory one is so I go to work directory one is startup. So there's no solution file here. So it's just a CS project. So you see what was this is a project. So it's not seeing it. It's not seeing a solution. So if I go to the Nugget, so it requires some troubleshooting, but I hope we all understood the process. It requires some troubleshooting here to get this solution here. So, but in subsequent training, we'll explain all this and do thorough troubleshooting to see that it works well. But this is just to give you a broad idea of how your pipeline will work. So let me do something now. Let me now do an update. Okay, let me build another pipeline. Can I, we still have some time, can I just do a simple .NET application, an empty .NET application then we push it to our repo, then we do a trigger. Can we do we have time? Can we do that? Let me just create a
Let's ask
simple.
let's ask our audience here. So is that
Let me just put an empty .NET application to finish within our time. So in 10 minutes time, we'll be done with that. So let me take you the
all
whole
right?
process of CI/CD from beginning. So I'm building a .NET Core app. So I'll call it stringify test web API, create a new solution. I say next. I'm using .NET 6.0. Enable Docker no. I create. So I've created why the application is creating. Let me come here. I go to my repo. I create a new repo. Well, let me use I call it test. The repository name. This name here. This one. And I come to my application. So this is my application. So let me run it. This is a test string. So I'll run it to make sure that it's working on my system. While it is running, let me go to tools and add my repository. I go to command line. Oh, well, well, just 9 minutes. Where is it? Where is it? Where is it? Where are you? Where are you? Where are you? Hmm. Why is one? Submission is running. So let me add a repository. Oh shit, which fast now? Hmm. Push now.
This. So we say git init. We have to initialize git in this repository. That's empty. So say git remote add origin. Now say git add. We add everything. Now say git commit message initial. Now commit. We'll now do git push use origin. Okay, this is this. We did all this, so so like you're asking the other day, what happened when I changed my repository? So it is not asking me to log in. So I need to log in now. Oh, sorry, please. I need to get that account. I don't. It's a new account. Hmm. Oh, so it's because I'm trying to change my location. Oh shit! Wait, we have some time.
No, go ahead. Go ahead. We have a few. We've been given a few more minutes. Go ahead.
Okay. Okay. So
So this is my repo now. My branch, my master branch. I have my application there. So let's go now to pipeline. Everything new pipeline. I use Classic Editor. I'm using Azure repo. So, okay, we have a restaurant app. So we're using a master branch. We continue. For Azure Web App Service, we are applying. Agent pool, then Super DevOps. Then solution, where's the solution coming from? It's this. Where's the solution? Our subscription. 25 tests. App service name. Yes. 25 tests. Web API. Go to deployment. Investment type, Windows. Package of folder. Close out. Save and kill. So our job is running on. See here, this shows that it's using the agent. It's come from my system. So you see, it's using Microsoft Visual Studio. So if I do it on my system, not run. So you see now. So that is all your build agent. Why did it break now? Oh shit. Ah, oh, thank God. Some
Those are the
fetching
things
that
we
has to
face.
be done here.
Those
Okay.
are those are the things we face.
Yeah.
That's the beauty of what we do,
Yes,
though.
yes. No, guys. So, but please, we'll still have another training on the so troubleshooting or have time to do a thorough troubleshooting, right? So, so these things are not they are not out of place. You always face this. Something may run before, now it's not running. So that is why you're paid what you are being paid. That's why you're one of the highest paid highest paid IT staff, DevOps engineer, because you do a lot. Most 60% of engineers. So coming to this role, always have that at the back of your head that 60% to 70% of your work is troubleshooting. So please, sorry about that, but that's how it is. If everything runs, you still your application on the app service. But this is just
Exactly.
what you need to do. But I will not show you how to do a trigger now because of time. We can create triggers. When we go to our pipeline, we can create a trigger that if there's any change, we now build it. But sorry about that, please. We'll continue again next time. Thank you.
All right, fantastic, 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 fantastic. That's the beauty of what we do. That's the beauty. It breaks, we sit, we fix, we debug, and all of that. And that's the beauty. Thank you so much, Okene. I think we've learned a lot. We've learned a lot. It's been a roller coaster. These 3 days, it's been a very interesting one. And I'm telling you that from the comments, from the questions, from people, they really enjoyed every bit of the session, and that's very important for us. Thank you everyone for joining. Like we said, also the videos, all right. The videos are on this YouTube channel, all right. So you can always track back, come back and watch them, and then drop questions on the comment sections. Even after now, if you have questions, if you scroll up the chat, my LinkedIn and then Ekene's LinkedIn is attached. You can always reach out to us for questions. And like we promised, by next week you would get the slides that was used. Would update it, add a few things, explain a few terminologies, and then we'll share the slide. And Ekene, some of them requested for the source code uh, that we use. Also, we'll see how we can also attach, the file to you for the source codes we use also, so that you can also engage in practice from your side. Okay, and like I said, before the end of this particular quarter, we'll definitely be having another session. All right, so to continue some of these things where we stopped, we'll definitely be having, if not in May, it will be in June. All right, we'll be having another session. And then, like I said, also as we go on, we'd also have sessions where we'd see how DevOps can be used for different instances, for people in low code systems, for people in for pro devs and all of those things like that. So uh, we have a lot in stock. Stick with us. We'll do a proper mail when it's time for our next sessions. Definitely, you will get our flyers, you get our publicity, and then you will be able to know about it. All right. All right. So thank you very much, everybody, for joining us. Uh, we'll see you again next time. All right. Please do have a wonderful uh evening, everybody, or afternoon or morning, wherever it is you are. I'll see you next time. You'll get an email from us next week. So do have a wonderful time. If your email, if you didn't register for this training and you just probably joined, please drop your email so that you can be part of the mail blast of the resources we've used. All right. See you all next time. And please, Love said, can we have one more day? So don't worry, love. You'll definitely get an update for the next session. And like I said, the next session we'll try and see how we can
That's
extend it.
serious.
To see how we can extend it. Okay, definitely,
Mhm.
definitely. All right. So thank you very much, everybody. Thank you for joining. Have a wonderful time, everyone, and then we'll see you all next time. Okay.